This is Math 3, Lesson 4.4 on solving rational equations. We are beginning, I believe it's on interactive notebook page 25. Might be 27, but I think it's 25. Okay, so, and on that first page there, you'll see a little definition of what a rational equation is. We talked before about rational expressions being fractions, and so rational equations are very similar. They have those fraction components. However, there needs to be an x in the denominator. So this one here is a rational equation. It has those x values in the denominator, and the difference between a rational equation versus a rational expression is this equal sign right here. Okay, so rational expression may have two expressions where you're multiplying or dividing or adding or subtracting or just simplifying, but they won't have an equation, an equal sign. When you see an equal sign, you're going to solve, and there's different types of solving. This one over here to the right is not a rational equation because the x value here is not in the denominator. And then this last one down here, a proportion is when you have a single fraction on each side. These ones are kind of nice because if you have one fraction equal to another fraction, you can use those properties that we use for proportions, which is to cross multiply. A lot of you do that really well, and so I'm going to do our first problem that way, and then I may show you another way that works as well. Okay. So I'm going to change my slide. There's an example here. In this example, I'm using a different method. It's using the LCD method or Fraction Busters method. And this method is not using the cross multiplying properties. You can see that your lowest common denominator in this example is the combination of these two. And so if you multiply that on both sides of your equation, the wonderful thing that happens is those 4x plus 5's cancel on the right and those x plus 1's cancel on the left, giving you a linear equation to solve. So that is the method I'm going to use. It is going to be new for a lot of you. Cross multiplying will still work. However, when we get to later problems in this objective, they get increasingly difficult if you are using that cross multiplying. Okay, so here's our first problem. Okay, and I am going to use that LCD method. So your very first step is to identify the LCD. Okay, oops, I didn't really want to use a red pen. Okay, so I'll write it down here. Step 1, find the LCD. And I can see here that these two denominators do not have anything in common. So that LCD here is going to be 5x times x minus 7. Let me fix this so it looks a little better. Okay, and then I am going to multiply that LCD on both sides of the equation. And the idea here is that you'll be able to reduce. Okay. Okay, so I'm going to write that equation down again. 3 over 5x equals 2 over x minus 7. That LCD is 5 times x minus 7, so I'm going to multiply it on both sides. And then I said that I wanted to reduce. Okay, so when I reduce that, I can see that my 5x's cancel. and my x minus 7's cancel. And I have something very similar to our cross multiplying. I end up with 3 times x minus 7 left over and 2 times 5x left over. Then I'm going to distribute and solve for x. Okay, so we get 3x minus 21 is equal to 10x. I'm going to subtract 3x on both sides. I get negative 21 equals 7x. Divide by 7, and I get an x value of negative 3. Okay, we will be doing a lot of checking our solutions. Right now I'm going to focus on just the solving component, but we will be coming back to that. It will be highly important. Next problem. The next thing I'd like you to do is work on number 4. And then I think it's number 6. This is on worksheet 4 in your interactive notebook. You just have to flip the pages a couple. It might be page 29 or 30. I can't remember. I don't have my check sheet in front of me right now. Okay. So I would pause here and try to complete those. When you select play, you should be able to check your answers to 1 or 2 of your questions. Oh, number 1 and number 4. There we go. Okay, and so I'm going to work as well. I'm going to find my LCD. Oops. Dang it. I'm going to multiply that on both sides. I'm going to reduce. I'm left with 3 times x minus 1 on the left, 6 times x plus 2 on the right. I'm going to isolate my x, so I'm going to subtract 3x on both sides. I'm going to subtract 12 on both sides. We get negative 15 equals 3x. And I get a final answer of x equals negative 5. Final answer. Okay, so check your work. Ask your teammates if you have questions. You can pause here. You can ask your teacher. Okay, let's try the next one. Number 7. Okay, my LCD in this one. X plus 1 times x minus 1. I multiply that to both sides. I'm going to reduce again. I'm left with negative 3 times x minus 1 equals 4 times x plus 4 plus 1. I'm going to distribute. I get negative 3x plus 3 equals 4x plus 4. I'm going to add that 3x to both sides. I get 7x. I'm going to subtract 4 on both sides. I get negative 1. I get x equals negative 1 over 7. That does not mean it's no solution. Fractions are A-okay. We're going to have lots of fractions in this class. Okay, saw in that SBAC practice, lots of fractions. Okay, so again, if you have questions, check with your neighbor, look through it. You can ask your teacher. Okay, Okay, the next part we're going to talk about is the category of no solution. No solution, there's going to be 3 different times that this comes up, okay? So if there's no real number solution, that means there's no real number answer to the equation. Okay, so when you're trying to solve an equation, sometimes you're going to get an answer that when you check it, it just isn't true. Okay, it's like a false positive. Sometimes you're going, and this week, I think this popped up before in Unit 2 when we were solving. Sometimes you result in only imaginary solutions, and those are not real. So I'm going to write that little comment down here. Imaginary solutions are not real. Okay, and I believe there's one on the test that says that you get an imaginary and then you have to determine that it is not a real solution. Is that dinner? Dinner's just about ready. When all apparent solutions do not satisfy the original equation. What? Okay, hang on, honey. Okay, so there is a difference between this one and number one. Number one, it produces an equivalent equation that isn't true, so it could say something like x plus 2 equals x plus 5, okay? And so there would be no way for this to be true, because if I were to like cancel out your x's, that would imply that 2 and 5 are equal, and they're not, okay? Whereas in this one down here, number 3, it says that all apparent solutions, that's where you get the false positives. You plug them back in and they don't work. So it would be something like if you got an answer to an equation like x equals 2 and you plugged it back into something like, I'm not sure, x minus 2 here equals blah, 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 blah. If you plug that 2 in here, you'd have a 2 minus 2 and you get that 0, which is undefined, and that wouldn't work. Okay, so that's when checking is important. Okay, so you're always satisfying the original equation. You're going to check things in the original equation. If it ends up being false, you'll call it extraneous. Okay, so that's going to come up very, very soon. Okay, our next one here. Here's one here where there's no solution. You can see that they, this one, it looks like the cross multiplying worked. Or maybe they did multiply by the LCD and then they reduced immediately. You can start doing some of that stuff in your head. When they distributed, though, they got 2 equations here. See here, the 2x cancels out. They get 6 equals negative 2. No x. This is not a true statement, so we say no solution. Okay, it's a false statement. Okay. Okay, so let's try one now. Okay, I'm going to do the same as we've done before. I'm going to calculate my LCD, and that would be, I'm going to run out of room if I write that big. Okay. Step 1, find the LCD, and that's x minus 2 times x plus 2. I'm going to multiply that on both sides. Okay, and so that's going to be x minus 2 times x plus 2 times 5 over x minus 2. And I don't like how big I'm sloppy. I'm writing again. Ow. Okay, and so when I reduce, I see that cancel, 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 cancel. I'm left with 5 times x plus 2 equals 5 times x minus 2. Okay, and then we want to solve. And so I distribute. I get 5x plus 2 equals 5x minus 2. But again, I end up with those equations. See how the 5x and the 5x are the same, but the 2 and the negative 2 are not the same? When I subtract that 5x on both sides, I'm getting a statement. 2 equals negative 2. It's not true. It's false. So we would say no solution. Final answer. Okay. The next topic here is going to be infinitely many solutions. Okay, so this happens very similar to no solution. When you solve, you're getting all your x's are canceling out, but you're getting identical equations on the left and right. And I can see that as early as this point, but if you don't recognize it and your x's cancel out, but that's true on both sides, you're going to say it's infinitely many solutions. Okay. So let's look here. We're going to do the same thing that we've been doing. Okay, I'm going to calculate my LCD. He doesn't want to be attacked, Annalise. He's going to come attack you. Look. It's very funny.
Go away. Look at Mama when I do this.
I know, he's going to attack you again. Watch. It's not even being all that sneaky. Okay, so I'm going to multiply that on both sides. Uh-oh.
Emily, can I put on your Kindle? No. Why? I don't want you to. Why? I don't want to. I could for 5 minutes. 30 minutes. Okay, 3 minutes now. I might not have time though.
Okay, I'm reducing just like before. So I end up with x times 3x plus 6
You can tell me what day.
is equal to 3x times x plus 2. And I'm going to distribute. End up with 3x squared plus 6x is equal to 3x squared plus 6x. Okay, again, they are identical on left and right. So as soon as I get this point, I know, okay, this is going to give me the exact same solution. Carter, I'm making a video. Can you please settle it down, please? Okay, and again, that's because it's identical on the left and right. Hey, Daddy, are you ready for dinner? Okay.
Daddy, tomorrow, Daddy's too dark, so why did you not let me do that?
So the next thing I would want you to do is go back to your worksheet 4. The next problem. No, actually, I can't remember. I'm not seeing it. This one has more than one solution. There was some I wanted you to try. I can't remember which ones they were because I think I clicked through it too fast. Anyway, is it right after this one? This one's going to talk about how you can have more than one solution. Okay, so I'm going to go ahead and walk you through this example. Same idea. We'll multiply both sides by the LCD.
I bet you it is on the computer.
Yep. I'm going to multiply it on both sides.
You think that is on the computer? My phone.
Okay, so when I do this and I cancel, end up with 2x times 3x is equal to 8 times x plus 1. So 2x plus 3x is 6x squared is equal to 8x plus 8. Now I have an x squared and an x, which means I have all the mixings of a trinomial. Okay, so I'm going to set it equal to 0 so I can solve the quadratic. Okay, so I'm going to subtract the 8x squared, or the 8x on both sides, and the 8. And when I factor, I see a GCF. That GCF is 2. Okay, and then I'm going to factor that, which is kind of crazy. I am not sure how that's going to work. But I'm going to go 3x times x. Okay, I want to do a 1 and a 4. So I'm seeing that I need a negative 4. I don't know how that's going to work. Let's see. What if I did a 2 and a 2? 2 and a positive 2. So that would go 2. That would be negative 6. And then I'm going to do a positive 2 here. Okay, and so when I check here, that would be 2x and negative 6x. That works. So then you set each factor equal to 0. And when I subtract, I get 3x equals negative 2. Divided by 3, I get x is equal to negative 2 over 3. And this one I get x is equal to 2. So I get 2 answers. I'd have to check them to make sure that they're true on both sides. It sounds hard, but it's much easier than it actually sounds, okay? That's how I'm getting 2 solutions there. Okay, so let's try number 4 on your worksheet 4. Again, remember to check for no solution, infinitely many solutions, or 2 solutions. Okay. Pause here and try this one. And when you unpause, you can watch my video of me doing it. Okay, so here the LCD is 3x plus 1 times 9x plus 3. I'm going to multiply that on both sides. Uh-oh. Okay, so then I get this and this cancel, this and this cancel. I'm left with 2 times 9x plus 3 is equal to 6 times 3x plus 1. Distribute, and I get 18x plus 6 equals, distribute, 18x plus 6. I can stop right here. It's identical on the left and right, so this is infinitely many solutions. And that's because the left and right sides are identical. If you think about it, if you were to plug in any number for x, like say plug in 1, 18 times 1, that's 18, plus 6 is 24. If I do the same on this, I'm going to get 24. Doesn't matter what number you plug in for x, it's always going to be the same. Okay, so the next one. Now try number 6 on worksheet 4. Pause here, and when you unpause, you can see how I do it. Okay, so my LCD is 3 times x plus 3. Okay, so I'm going to multiply that on both sides. And when I do, on this side, the x plus 3 will cancel, so I'll just have 3 times x minus 4 equals, and on this side, the 3's will cancel, so I'll just have x times x plus 3. This is going to be a little different. Okay, distribute, I'm going to get 3x minus 12 equals x squared plus 3x. I am going to subtract 3x on both sides. I'm going to end up with negative 12 equals x squared, and when I square root, I get absolute value of x is equal to, remember the square root of negative is an I, and then 12 is 4 times 3, and square root of 4 is 2, root 3. Okay, and so then x would be plus or minus 2I root 3. But if it's asking you for all real solutions, I'd say no real solution. And that's because this is imaginary. Okay. Okay. All right, and so this next example is very similar to the others. We're still going to multiply by the LCD. However, we have a trinomial in the denominator here, and so we are going to need to factor that before we can identify the LCD. Okay, so let's do that first. Factor the denominator. Okay.
3, 2, 1, go.
So I'm going to end up with 8 over x minus 2, x minus 7, and you should be checking that. I checked it in my head. That one is factored, and then there's no denominator on the 1, making an invisible 1. Then we want to multiply by the LCD every single term. I'm going to say expressions. Okay, I am going to run out of room on this slide, but I'm going to continue on the next one. I think you have like half a sheet of paper to work this one out. Okay, so I'm going to multiply everything by x minus 2, x minus 7. That's going to be our LCD. Okay, so when I do that, I'm going to be multiplying it here to the 8. So I'm going to write it down, but I tend to do a lot of this in my head now. Okay, and then minus 3. Equals 1, and then I'm going to multiply that one as well. Okay, so I'm going to show how I'm going to cancel, and we'll show my next step on the next slide. Okay, so I have to keep track of what I'm doing. Okay, so I'm going to have just 8 left over on this one. I'm going to have a minus 3 and an x minus 2 on that one, and then here I'm going to have all of this, but the 1 can be invisible. Okay, so let's see if I can remember that. Okay, so that was just an 8 for the first one, minus a 3 times an x minus 2 for the second one, and then the 1 times it was x minus 2, x minus 7. Okay, I will need to distribute this one here, and I will get an 8 minus 3x plus 6 equals, and this is kind of nice because we already factored that earlier. It's x squared minus 9x plus 14. So I have all the makings of a trinomial. I can see here that I have an x squared and then I have multiple x values. Darn it, I don't know why the highlighter's not working. Oh, now it's showing up delayed, I guess. So we want to set it equal to 0 and do some trinomial factoring. The x squared is on the right, so I'm going to move everything else to the right as well. And I'm lining everything up here so that I have all my like terms. So negative 9x plus 3x is negative 6x. Negative 14 and negative 8 is 6. And 6 and negative 6 is 0, so those cancel out. So now I'm just left with GCF factoring. And then I have two factors, x equals 0 and x minus 6 equals 0. And so the first answer is going to be x equals 0, and the second one is going to be 6. Now it is important to check all solutions every time you do this. So if we look at that original equation, we had an 8 over, and then it was the x squared, right? So I'm going to plug in the 0. Oh, I don't know why I put a 0 here. 0 squared minus 9 times 0 plus 14. And then I had the minus 3 over x minus 7, so 0 minus 7 equals 1. This is all going to reduce to 8 over 14. And then I'm going to have minus a 3 over negative 7, giving me positive. Okay, if I multiply this by 2 over 2, then I can get a common denominator. And so then this will end up being 8 over 14 plus 6 over 14 equals 1. And that works out because that would be 14 over 14. Okay, so that would be my first answer. That one works. Oh, I never wrote down my other answer here. Darn it. Okay, so 6. So now I need to try, oh, my 6. Ooh, that looks not so good. Okay, so now I would plug 6 in, and so that's going to give me some pretty big numbers. I should probably clear this up just so I can show that I can make room for it. Okay, and so when I plug in that, I'm going to have 8 over 6 squared minus 9 times 6 plus 14 minus 3 over 6 minus 7 equals 1. Okay, so I'm checking that. And then that would be 8 over 36 minus 9 times 6 is 54 plus 14 minus 3 over, it's going to be negative 1 equals, 1. Now when you're checking, you never go over the equal sign, okay? So negative 54 and let's see, positive 14, I believe that's 40. Oh, I don't know if this is working. Negative 40? I think so. Dang it, I was going to try to use a calculator real quick. Oh, I got another one. Never mind. Okay, so 36 minus 54 plus 14 is negative 4. Okay, so 8 over negative 4 plus 3, does that equal 1? Well, that would be negative 2 plus 3. And sure enough, 1 equals 1. So that one checks out as well. So on the test, it's going to ask you how many solutions, and you're going to say 2. I should probably not be so sloppy though. Maybe rewrite that. Okay, now let's see which one should we practice from worksheet 4. Go ahead and try this one. Pause it here. It's the same level of difficulty. Remember, you're going to have to factor first. When you resume, you can check your answer by looking at mine. Okay, my LCD is, I got to factor that first. 4x plus 1 over x plus 1 equals 12 over x plus 1, x minus 1 plus 3. So my lowest common denominator is x plus 1 times x minus 1. So I'm going to multiply that everywhere. And when I do, the x plus 1 will cancel here and here. So I'll have 4x plus 1 times x minus 1. Both of them will cancel here. So I'll have equals 12. And then here nothing will cancel. So plus 3 times x plus 1, x minus 1. Okay, so I have to FOIL this. That's going to be 4x squared minus 4x plus x minus 1 equals 12 plus 3. This is x squared minus 1. I can combine some like terms. That's 4x squared plus 3x. I could subtract 12 on both sides, and that would be minus 13, and then distribute the 3. Okay, so now I can move that over, and when I subtract, I get 2x squared. I still have the plus 3x, and if I add 3 to both sides, I get negative 10. Okay, so I'm hoping I can factor this. Okay, so that would have to be a 2x and an x. I need a negative. If I put a 5 here, I'd have 10, but then that would be 10 minus 2, so that's not going to work. So I think I'm going to go 2 here and a 5 here. And so then this one I want positive, this one I'll make negative. No, because then that would be 5 minus 4, and I don't want 5 minus 4. So what I want is 5. Oh, you know what? I subtracted wrong. Ha ha ha. Okay. So 4x minus 3x is not 2x squared. It's 1x. Okay, so then that would be 5x minus 2. So that'll work. So that means I have two answers. My x equals negative 5 and x equals 2. But I should check those in my original. So if I do that, I'd have 4 times negative 5 plus 1 over negative 5 plus 1 equals 12 over negative 5 squared minus 1 plus 3. That would be negative 20 plus 1 over negative 4 equals 12 over 25 minus 1 plus 3. Ugh, I'm not loving this sucker at all. Nope, 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 nope. That's going to be negative 19 over negative 4. Okay, I have to clean up a little bit. Negative 19 over negative 4, which would make that a positive, equals, that'd be 24, 12 over 24. Ooh, that is not looking right. I wonder if I made a mistake somewhere. 4 multiplied by the 4, I got negative 20, plus 1 is negative 19, and then I have negative 5 plus 1, that's negative 4. Okay, and then 12 over negative 5 squared. 25 minus 1 is 24. I don't know. This is not looking quite right. Okay, so if I simplify that, that'd be 19 over 4 equals 1/2 plus 3. And so this would be 3.5. Okay. But what I'd want to do is multiply by 2, multiply this one, because I want a common denominator, right? So I multiply by 2 over 2. So that'd be equal to 1/2 plus 6 over 2. Okay, and so that would give me 7 over 2, which is not 19 over 4. Ugh, I'm not sure where I went wrong. I'm pretty sure that one's supposed to work. Maybe not. Okay, so right now I'm going to say it's not x is -5 because I'm not getting the right outcome. Okay. Okay, so let's try the 2 and see what happens. Let me see. When I did negative. Oh, I see what happened. You see it? Right here. When I said 4x and then I added the x, it was -3x. So then that would change this and this, which would make that a +5 and a -2. Okay, so now let's try that again. Okay, so I'm going to plug in a +5. So 4 times 5 plus 1 over 5 plus 1 equals 12 over 5 squared minus 1 plus 3. So that would be 20 plus 1 over 6. Is that equal to 12 over 25 minus 1 plus 3? Okay, so 20 plus 1 would be 21 over 6. And we know that that's 12 over 24 plus 3. Okay, let me erase some here up the top. Okay. Okay, so then that would reduce, I can divide by 3 and I get 7 over 2. Okay, and then this one I would get 1/2 plus 3, and I can do the 2 over 2. I get 7 over 2 equals 1/2 plus 6 over 2, and that will give me my 7 over 2, making that answer work. Okay, so I'm going to highlight that one. That one's a good one. Okay, now, change back over to my pen. Come on, sucker. Uh-oh, I think I locked it up. Dang it. Oh, don't do that to me now. Okay, so I'm going to check this on the next one. Let's see, on this next slide. So hopefully I don't mess this up. Okay, so it was 4 times -2 plus 1 over, and then I believe it was -2 plus 1 equals, and then it was 12 over -2 squared minus 1 plus 3. Ooh, I hope I wrote it down right. Okay, so 4 times -2 is -8 plus 1 over -2 minus plus 1 is -1. That'd be over 12. 4 minus 1 plus 3. -8 plus 1 is -7 over -1. So that'll end up being a +7. And then 12, 4 minus 1 is 3. So 12 divided by 3. And then 12 divided by 3 is 4 plus 3. So I do get 7 equals 7. So that means that my answers were x equals 5 and x equals -2. 2 solutions. Okay, let me highlight those. Okay, I think I have one more example to show you, and this is where when you check them, they don't both work, okay? Okay, so here we go. It's a complicated one. There is one like this on the test, so you want to make sure you definitely try this, pay attention, take good notes, okay? So here again, we want LCD, but I need to factor it first. So I'm going to say 9 over x minus 2 plus 6x over x plus 2 equals 9x squared over x plus 2, x minus 2. So I'm going to multiply that x plus 2, x minus 2 to all of this. Okay, so when I do, this and this will cancel out, but I'll be left with x times 9 times x plus 2. This and this will cancel, but I'll be left with 6x times x minus 2. And then on this side, I'll have both cancel. So I'll be left with 9x squared. So when I distribute, I'll get 9x squared plus 18 plus 6x squared minus 12x equals 9x squared. The 9x squared on both sides will cancel. And then if I put this in order, I'll have 6x squared minus 12x plus 18. The GCF is 6, I could factor that out. Okay, and that's not seeming right. Something doesn't quite seem right. So if I do -3 and I wonder if I multiplied something wrong here. Oh, this wasn't 9x squared, it was just 9x. Okay, so I do need to fix that. I should probably not do this stuff late at night. Okay, so that's 9x. Okay, I think all that stuff is good. Okay, but then I gotta clean this up a bit. Okay, so 9x squared here. Okay, so I'm going to want to move everything to the other side then. So I'm going to say minus 6x squared. Get rid of it here. And then I want to add the 12x on this side. And I want to subtract the 9x on that side. And I want to subtract the 18. That way I can get a 0 equals 3x squared plus 3x minus 18. Now my GCF is a 3. I can factor that out. Okay, so then I could have 3 times x plus 3 times x minus 2, giving me x equals -3 and x equals 2 as possible solutions. But then I gotta plug them back in. I'm just gonna plug them in up here at the top, okay? So if I plug in a 3, 3, 3, those are all negative. Okay, so then that would be 9 over -5 plus, I need a -3 in there, plus -18 over -3, my plus 1 is -1, equals, -3 squared is 9, 9 times 9 is 81, oh my goodness, over 3 squared is 9, 9 minus 4 is 5. Okay, so this one here, I'm going to get a positive 18. And then I have a 9 over -5. I need to get a common denominator there, so I'm going to have a 9 over -5 plus, I'm going to multiply this one by 5 over 5. Let's see. 18 times 5 is 90. And then 90 plus -9 is -81. No, positive 81 over 5, which equals positive 81 over 5. So that one worked. Sweet. Okay, I gotta clear this up so I can make room, okay? Okay, let's go do it again. Okay. I was more patient this time and it worked out better. Dang it, gotta wait. Okay, clean that up a little bit, clean this up a little bit. Okay, so this time I'm going to plug in the 2. Okay, so 2 minus 2, that'd be 9. Uh-oh, I can already see that that's going to be a problem. So I'd have 9 over 2 minus 2 is 0, and I can't have 9 over 0. So this one gives me, it's actually an excluded value because it creates a 0 in the denominator. So I'm going to write that down. Yeah, I'm almost done. 2 is not a solution since it creates, well, I guess I need an either, a 0 in the denominator. Okay. All right, and let's see if I have any more for you guys to practice. Keep working. Okay, so try this one, number 17 on worksheet 4, and then you are welcome to work on everything at home. Okay, so I'm going to try that out. I'm going to factor. This would be x squared, x minus 4x minus 2. So I'm going to multiply that to all sides. Okay, so when I multiply that here, that and that will cancel. We'll get x times x minus 4 minus 2 times this and this will cancel. So 2 times x minus 2. And then this, all of that would cancel with all of that. So I'd have 4x minus 12. When I distribute, I get x squared minus 4x minus 2x plus 4 equals 4x minus 12. That gives me x squared minus 6x plus 4 equals, let's set up a little bit, 4x minus 12. But if I subtract 4x on both sides, I get x squared minus 10x. If I add 12 to both sides, I get 16. And then if I go x minus 8, x minus 2, I get 0. It's not funny, Carter. X equals 8 and x equals 2. Okay, so I'm going to plug those in. So if I plug in 8, I have 8 over 8 minus 2 is 6, minus 2, 8 minus 4 is 4, equals 4 times 8 is 32 minus 12 over 64 minus, here, I'll pause. Okay, so let's see here. Let's see, so I was doing 6 times 8 is negative 48. And then I have the plus 8. Okay, so this would be a 1/2, and that would be, okay, so I'm going to reduce that. 8 over 6 is 4 over 3 minus 1 over 2 equals 32 minus 12 is 20. 64 minus 48. 64 minus 48. Is that 16, Daddy-O? 64 minus 48?
64
minus 48.
16.
That is 16, right? Okay. And then 16 plus 8 would be 24. Okay, and so then that would be, I'm going to divide by 4, so that'd be 5 over 8. Okay. Then here, I don't know, is that right? Divide by, I don't think so. 5 over 6. Okay, so then I'm going to multiply this by 2 over 2 and this by 3 over 3. That gives me 8 over 6 minus 3 over 6, which guess what is 5 over 6. So the 8 worked. Okay, now I'm going to clean this up so I can check my other one. Okay, so here we go. I'm plugging in a 2, so that'd be 2 over. Uh-oh, I have that same problem come out. Do you see what happens? If I have 2 over 2 minus 2, 2 creates a 0 in the denominator, meaning that it cannot be an answer. Okay, so I'm going to erase this, but then explain my reasoning. 2 is extraneous because it creates a 0 in the denominator. Okay, so only 8 is an answer.
Captain knows people will blame his friends, Bucky Barnes, for the explosion. Bucky used to do bad things.
All right, and that concludes this. Good luck with the rest of your homework. I hope you enjoyed the lesson.